SciPy is a Python library used for scientific computing. It provides tools for tasks like optimization, integration, statistics, linear algebra, and interpolation. You can install it by running pip install SciPy in the command prompt. Additionally, run pip install matplotlib as well. Matplotlib will allow us to make some plots in this video. Import NumPy, SciPy, and matplotlib at the start of the Python file. SciPy is divided into different subpackages. For example, from the SciPy constant subpackage, we can import pi and golden ratio and print their values. Now we will learn how to interpolate with SciPy. Suppose we have a few data points. We want to estimate the values within the x interval. We can interpolate the data by making piecewise quadratic curves past the points. We can use the curve to calculate y values for any x value in the range. In code, we will define the data points. We will call the interp1d function from SciPy interpolate on the x and y values with the quadratic option. There are other options you can choose like linear or cubic. We will define some experimental x values which do not have any corresponding y values in the original data. We can call the model on the experimental x values to find the interpolated y values. We can print it out to see the result. We can also plot the curve and see the locations of the interpolated y values for the experimental x values. However, interpolation is not very smart as it forces the curve to pass through every single data point. If we want to fit a specific equation with all the parameters to the data, we can use the curve fit function. First, import curve fit from SciPy optimize. Next, get the data you're trying to fit to. This data has a quadratic shape, so I will define a function model that takes parameters a, b, and c. X is the input value to the function model. Call curve fit on the function and the x and y values. It will return the list of best fit parameters. This can be inputted back into the function model to get the best curve to fit the data. We can plot the original data points and the curve, and we can see that the curve fits the data accurately. Another useful function from SciPy optimize subpackage is minimize, which can be used to solve minimization problems. In minimization, we'll be minimizing a particular objective function beginning from a certain initial condition. We can call minimize on the function and initial condition to get the solution. The solution has a few items, but we are looking for item x, which is the list of parameters that return the minimum value. In this case, if you test the solution, the function will return 0. We can also try adding constraints to this problem. We will add two types of constraints. The first constraint is an equality constraint. We will define the function such that when the constraint is satisfied, the value is 0. The second constraint is an inequality. So we will define the function such that the inequality constraint is satisfied when the function returns a value above 0. We will define the list of constraints to pass to minimize. The list will contain dictionaries with the fun key mapping to the constraint function and the type key mapping to the type of constraint. eq is an equality constraint and ineq is an inequality constraint. We can pass the list of constraints to minimize. However, if you run this, you will get an error because we also need to define the method that works with constraints. We will use the method slsqp. Now the minimization works correctly. You may also want to add bounds to the values. To do that, you can define the bound for each parameter in a list and input it into the minimization function. SciPy also has powerful linear algebra features. Suppose you need to find the solution to the following equations. You can represent the equations in a matrix format and then call solve to find the solution to the equations. SciPy can also be used to find the determinant and inverse of a matrix, which are both important properties of a matrix. The EIG function can be called on a matrix to find the eigenvalues and eigenvectors of a matrix, which can be used for procedures like principal component analysis. Next, we will learn how to cluster data in SciPy. Suppose we have the following points of data. We can see that there are 3 clusters of data. The crosses are the centers of each cluster, which are called centroids. We can use the k-means algorithm in SciPy to perform the clustering. In the code, we will import k-means2 from SciPy cluster vq. This is the data we will be using. Let k be the number of clusters to create. We can call the function on points and k and it will return the centroids and labels. Centroids are the coordinates of the points at the center of each cluster. Labels is an array of values. Each data point has an integer label. The points in the first cluster have label 0. The points in the other clusters are labeled 1 and 2. We can find the points belonging to each cluster using the 3 lines of code shown. SciPy can also be used to integrate functions. Suppose we want to solve this integral. To do that, we will call the quad function. First define the function itself. Then call quad on the function and the bounds as well. The result will contain the solution and the error of the solution. You can also calculate double integrals by using dbl quad function. Input the function, then the bounds of the first parameter, and finally the bounds of the second parameter. The return value is once again the solution and the error of the solution, and you can print it out in the console.